quotient and remainders. Okay, so quotient, remainder, and these are the very small topics. That's why I'm kind of covering. I don't have a lot to do. Pretty much practice that you have to do it on these topics. Okay. Okay. The quotient and remainder is more on the practice side, not really much to learn. But I will do a quick revision on. Always does this. Okay. And if I make a mistake when I'm teaching you and you guys know it, please feel free to tell me. I would be happy to correct it, including my spelling mistakes. When I'm talking and writing and also thinking what type of examples to give you, it's easy to make mistake. Okay. So quick reminder, a quick revision on the concepts. The mathematical operators we learned, right? The plus, minus, division, multiplication, right? These four. We also learned 2 forward slashes for something and percentage sign for something. Who can tell me what is these 2 forward slash mean? Dev?
That it means that you want to divide twice.
Nope.
It's if you only want the whole number, you don't want decimal.
Correct. Right. So suppose you say 22 divided by 7. If you do 22 by 7, you will get 3.14 or something. But I'm interested in only this piece of number. I don't want the result as 3.14. I want only 3. So if you convert it to mixed number, it's going to look like this. Now, this is called quotient and this is called remainder. So if you want to find this piece, you have to do 22 forward slash 7 and you get 3. If you do 22 percentage 7, you'll get it 1 because this is remainder and this is quotient. So this part is this one and this one is this. Got it? And we also learned a function in math in Python that gives you both of these numbers together, right? Can someone tell me what is that function called? Pranav? Using a Python function, how can you do division and how can you get quotient and remainder in one go without using these 2 mathematical operators? How do you get it? It's called div mod. If I say div mod, we just learned it last class. How did you guys forget about it? And you say 22, there are 2 parameters div mod function takes. Div mod, and first parameter is the number on the top, comma, second parameter. Remember, parameter, you use comma to separate the parameters. So 22 and then 7. If you do this, you will get it as q comma r. This is one of the functions that returns 2 values. One first value will be quotient, which is 3, and r will be remainder 1. Got it? You can do manually also like this. You can do this, or you can use div mod function, pass 2 values as an input, the numerator and denominator, and you get quotient and remainder both together. And we learned this in the last class. Okay. Now, this is how you get all this. But where do you really apply? And I had told you in the last class that we'll talk more about it. Okay. So where do you apply? Where do you get all of this? There are several uses I can think of. Okay. The one is like, you can call it like, when you want to split a number into individual digits. Like if I give you a number, let's say 3581, right? And I ask you to add these digits into find the sum of these digits. How will you do that? Right? How do you get it?
The sequence function or fsum would it be?
What is that?
The math.fsum.
F sum? No, but I want you to find using the, I mean, I'm sure there are, there are functions already available in Python, but suppose somebody asks you to write a code, write a program that adds these numbers. How will you do that? What's your algorithm? What's your logic of adding these numbers? I'm sure somebody has written a function to do this, but if you have to write a program, how will you do this?
Y is equal to 3 plus 5 plus 8 plus 1, and then print y.
Yes, but how will you find 3? But I gave you a whole number, 3581. How will you get individual digits out of this?
Make them integers with the int function.
Yeah, but int will convert this whole 5. So suppose you enter 3. So int, what int does? So if you do like this, so int will take the string and convert this into a number called, suppose a. So a will be actually 3581 as a number. It is an integer a string right now, 3581. It will convert to a number, but you will not get 3 one time, 5 one time, 8 one time, and 1 one time. I mean, one by one. You will not get it. Integer function is to convert a string number into a number. Okay, this is where our idea of remainder and divisor works. So how about if we divide 3581 by 1000, and what will be the quotient you will get? And actually I should write it like this. You get 3581, right? You divide this by 1000, you will get, let's say this is your quotient, this is your remainder. Okay, what will be the quotient? Who can tell me? J, if you divide 3581 by 1000, what will be the quotient? What will be the whole number? J, you're on mute. Ishan, what do you think?
Can you please repeat that?
What would be the quotient, Ishan?
Quotient in this, the quotient would be 3,581.
No, quotient would be 358 and remainder would be 1. Take a smaller number. 35 divided by 10. You write 3, 5 over 10, don't you?
Yeah.
So you see, since you're dividing by 10, you are leaving out 5 as a remainder, and this becomes your quotient. Similarly, if you should 33 5 divided by 10, it will be 33 5 over 10. That means you always take this out. But if I want to take 358 out of 358, am I doing it correctly? Yes, it will be 358. No, I'm not doing it correctly. My bad. This one I'm not doing it correctly. This is not 358. This will be 3000 and this will be 581. Correct?
Yes.
Now, if I take remainder 581 and divide this time by 100, then my quotient will be 5, remainder will be 81. If I take 81 and this time I divide by 10, my quotient will be 8 and my remainder will be 1. That's it. So you can see how by doing this, we got this out, we got this out, we got this out, and we got this out. Right? Now I can, so your goal is to split or burst the number into individual pieces. individual digits 3581, and the way you do it is you start dividing by 1000, take quotient, take remainder. Again, whatever was the remainder in the last piece, you take and divide this time by 100. Whatever was the number, now you again do this by 10. So in 3 or 4 steps, this is what I call it algorithm. This is your solution of a problem. Now you know it. We will focus on how to convert this into a Python code, but that's a secondary. Your logic or your algorithm has to be independent of the programming language. Make sense? Right? Isn't it? Okay. So now that we see it, we can write this into a Python program, and I'll show you how to write it in the Python program. So let's write this code in Python, and I'm gonna share the screen here, share here, and let me know when you see my screen. Okay, let's say number equal to, and I'm gonna do chaining of the function, and all of you know, right? Enter your number, gives a little bit of space here. What will happen is I'll take, and I'm doing quick, when I talk, I also do a quick revision sort of, so that you guys don't forget it. Okay. So this is my inner function, input, and this is my outer function. The inner function's output goes into the outer function, and then when outer function evaluates, it finally goes into this. You can see when I use two functions, literally I have 3 boxes. So you always solve inside out. That's how Python always works. It first executes input statement. That means it will wait for you to enter the data. Whatever data you enter it will move to int function, becomes input to int function, because you are putting it inside the int parenthesis. And the int function converts and finally puts into the number. I could have also taken this and put into 2 separate state lines. So, if you want, I can say number 1, I can remove this. Let's first take the input. This input will be a string, number 1. And then I'll take number 1 and convert to number. Okay, anyone, any doubt? Now let's say it's a digit 1. Let's say digit 1 equal to my number, this 1000. This is what we just did it. And remainder will be number percentage 1000. So first one will give me digit 1, and second will be the remainder. In the next step, it's all a matter of copy paste, and I can change this. I say digit 2 equal to, this time it's not with the number, this time it will be the remainder, and I'm going to divide it by 100. That's what we did it, isn't it? And then this thing again will be my remainder, and my new remainder will be, so look at statement number 8. What we are doing is, in algebra you can't write this, but in math you can. You first take R, which is in line number 5. Pay attention please. Line number 5, you calculated remainder first time, and that remainder I'm going to divide it by, this time, 100 in the second step, and that will give me a new remainder, which I will overwrite it and put it in my same variable R. I could use R1, R2, R3, but I really don't need. I'm interested only in digit 1, digit 2, digit 3, like this. So I can keep overwriting my remainder. So the digit 3 would be R, this time divided by 10, and this also be 10, right? And in fact, the last one would be my digit 4 actually. It's not even remainder, because I know it's 1 digit left. So sum would be digit 1 plus digit 2 plus digit 3 plus digit 4. And then I will print my number. The sum of digits is, I'll say, sum. Okay. So we'll go quickly one by one. You take input, enter your number. I got number 1. And then I converted that into an integer. So I got my number. Now this is what I really need to work on. So first time I want to find the remainder, quotient of in order to find the first digit, I want to divide it by 1000. And then same number I'll divide by 1000 to get the remainder. So if you suppose you take the number 1234, or let me take 6993. So first time when you divide by 1000, digit 1 will become 6 and 993 will become my remainder. Now from second digit, I'll take the remainder, which is 993 this time, and I'll divide it by 100. So my digit 2 will be 93, and 9, and remainder will be 93. Now this time I will be, number is 93, R. Now 93 quotient 10 is 9, and 93 percentage 10 is digit 3. You got 6, 9, 9, and finally digit 4 is 3. And then I added all this and this. This is where, and there are a lot of applications of this remainder and division. That is why I taught you, and this is very important actually. When you do this, you will see a lot of uses. I will pause and ask, are there any questions on this topic? On this program, I mean. When you will be writing code, you need to learn. Just knowing how to get remainder and division is of no use. It's like you are having a car at your home. It's of no use unless you know how to drive it. So, by using it in code, you really, make it part of your toolbox, this function. I could also use, everywhere you notice, I used the mathematical operator, 2 forward slash for quotient and percentage for remainder. I could have used it in a single function. And how? It's a digit 1, comma, R equal to div mode and pass number and 1000. And I can do this in single digit. So I'll comment this out, and this is how I could have done that. Let me run this program. Okay. And I'll say 6993 and sum is 27. Right? So I could have used div mode. I can use the mathematical operator, both are fine, as long as whatever you're feeling comfortable. But it's always good to write optimal code in Python. People don't write a lot of lines of code. So rather than writing 2 lines, I would rather use div mode functions and write only 1 line.